All right, so what we're going to call this is going to be Chapter 5, Special. Okay, that's the title of this, Chapter 5, Special. We are going to do some work in your notebook, but for graphs, I want us to graph on graph paper, just because it's easier to graph on graph paper. So what I want you to do is I want you to go ahead and graph this problem right here. And then maybe you'll figure out why I call it special. So that first one, remember, starts on -2. And this slope, remember, is up. Okay.
What's that top one?
Where? Which top number?
The one on the one you wrote.
1?
Oh, okay.
1/4? Okay, I'm going to draw this line here. Okay, this has the same slope, doesn't it? Okay, what happened? What's the graph supposed to look like on all the systems? It's supposed to be an X, right? I didn't get an X. What did I get instead?
Parallel lines.
Parallel lines. So what do we know about parallel lines? They never cross forever and ever and ever and ever, right? So it's never going to make an X. So if I don't ever get an X, that means I'm going to get right? Remember, same slope equals parallel lines which is going to be no solution. Okay. Let's go ahead and move on to the next one. Number 2. I'm going to have to put this in slope-intercept form, yes? And I need to fix something on it. Go ahead and change this. This is not right. Go ahead and change this to, what is it supposed to be? This is not supposed to be 3. This is supposed to be 6. So in order to get the right answer, you're going to have to change it. Of course, remember we just do this. And it becomes and then what I do. So then my line becomes this. Okay, now graph the two lines. Okay, I'm going to graph the second line in purple. It starts -2. Okay, what happened? How come I have one line? Are those the same line? Okay, that could happen in one of our problems. If that happens, we're going to say many solutions. Because it doesn't just have one x, does it? It touches the entire line, right? So many solutions. So same line. Is going to equal many solutions. Okay. I'm going to do this next problem is going to be overly easy. You don't need to do it on the graph paper anymore because sometimes we have problems that we can't graph. And I'll make this overly easy. You can't see that. Okay, we're not going to graph this. I recommend let's go ahead and just use the combination method. I need to find and create an opposite, right? Let's see here. I can create an opposite here if I multiply everything by what? -2? Yeah? Okay. So this is going to be a -4x, -6y, -16. Okay, I have an opposite, don't I? 4 minus 4 is? Cancels. 6 minus 6 is? Cancels. 4 minus 16 is? Okay, something's wrong with this problem. Both my x's and y's canceled, didn't they? How am I supposed to solve the problem if my x's and y's are gone? Well, let me ask you another thing. Does 0 equal negative 12? No solution, parallel lines, right? So this is an example of a broken problem. Everything so far has had an answer, right? So there are times where, because these are parallel lines, we're not going to get a solution. Okay? Okay, I'm going to do one substitution, and then we're going to put up, and we're going to do all this work tomorrow. And we're going to do more examples. I just wanted to introduce it to you today. So let me go ahead and write this one down. Okay, I'm going to do substitution. Step 1. Step 2. I got to substitute this in, right? Because I'm substituting y for this. That equals 6. Okay. Let's work this out. Negative 2 plus 2 is what? Plus 6 equals 6. Okay, that's bad. My x's are gone, aren't they? So, tell me, does 6 equal 6? Okay, so there is a solution. This one was going to be many solutions. Same line. Okay? So those are the two things we're kind of adding. We're going to do some practice with this, practice on a little bit more. We're going to do inequalities, and then we'll take our final test. Yeah, you can put up, and we can get ready to move on. Monday is done.